Let's work through this triangle carefully because the key to this problem is not finding the two missing side lengths individually, but recognizing what information the perimeter and the Pythagorean theorem give us together. We have a right triangle with vertices P, Q, and R, and the right angle is at R. The hypotenuse is side PQ, and its length is 25 units. We're also told that the entire perimeter of the triangle is 60 units. Our goal is to find the exact area. Now, before we start calculating, notice that this diagram can look a little intimidating because two side lengths are missing. You might immediately think, okay, I need to find both of those sides first. But actually, we can avoid doing that completely. We only need their product, so let's call the two perpendicular sides x and y. These are the two legs that meet at the right angle. Now, let's begin with the perimeter. Remember, the perimeter of a triangle is simply the sum of all three side lengths. So we add x, y, and the hypotenuse, which is 25. Since the perimeter is 60, we can write x plus y plus 25 equals 60. Now let's isolate x plus y. We subtract 25 from both sides. On the left, the positive 25 cancels with negative 25, leaving x plus y. On the right, 60 minus 25 gives us 35. So we have x plus y equals 35. Pause here for a moment because this is our first important piece of information. We now know the sum of the two legs, even though we don't know their individual values. Now let's use the fact that this is a right triangle. Whenever we have a right triangle, the Pythagorean theorem tells us that the square of one leg plus the square of the other leg equals the square of the hypotenuse. In our case, the legs are x and y, and the hypotenuse is 25. So, we write x squared plus y squared equals 25 squared. Now, 25 squared means 25, multiplied by 25, which is 625. Therefore, we get x squared plus y squared equals 625. So at this point, let's organize what we know. From the perimeter, we know that x plus y equals 35. From the Pythagorean theorem, we know that x squared plus y squared equals 625. And now comes the clever part. We are trying to find the area, and because this is a right triangle, the area is 1/2 multiplied by the base, multiplied by the height. Our two perpendicular sides are x and y, so the area is 1/2 multiplied by x, multiplied by y. In other words, the only thing we really need is the product x, y. We do not necessarily need to find x and y separately. This is where a very useful algebraic identity comes into play. There is a standard identity that says the quantity x plus y whole squared equals x squared plus y squared plus 2 multiplied by xy. Now look at how perfectly our known information fits into it. We already know that x plus y equals 35. So wherever we see x plus y, we can replace it with 35. And we also know that x squared plus y squared equals 625. So let's substitute both pieces of information into our identity. We get 35 squared equals 625 plus 2 multiplied by xy. Now, let's calculate 35 squared. 35 multiplied by 35 is 1,225. So our equation becomes 1,225 equals 625 plus 2 multiplied by xy. Now our goal is to isolate the product xy. We have 625 added to 2xy. So we need to remove that 625 from the right-hand side. We can do that by subtracting 625 from both sides. On the left, 1,225 minus 625 equals 600. On the right, the 625 cancels, leaving 2 multiplied by xy. Therefore, we have 2xy equals 600. Now we want xy by itself, so divide both sides by 2. 600 divided by 2 is 300. Therefore, xy equals 300. And notice how useful that is. We never had to calculate x and y individually. We went directly to the exact product that the area formula requires. Now we're essentially at the finish line. Let's return to the area formula for a right triangle. The area equals 1/2 multiplied by x multiplied by y. We have just found that xy equals 300, so we can substitute 300 directly into the formula. That gives us area equals 1/2 multiplied by 300. 1/2 of 300 is 150. Therefore, the exact area of the triangle is 150 square units. And that is our final answer, 150 square units. Before we finish, notice the elegance of the method. We were given the perimeter, which allowed us to find the sum of the two legs. Then the Pythagorean theorem gave us the sum of their squares. Instead of solving for the two unknown sides separately, we use the identity involving the square of their sum to find their product. And because the area of a right triangle depends directly on the product of its two perpendicular sides, that product gave us the answer immediately. So the important chain to remember is this. The perimeter gives us x plus y equals 35. The Pythagorean theorem gives us x squared plus y squared equals 625. The identity for x plus y, whole squared, gives us xy equals 300. And finally, the area formula gives us 150 square units. If this kind of algebra shortcut makes geometry easier for you, take a moment to like the video, subscribe for more problems like this, and comment below with the part of the solution you found most useful. The main lesson here is simple. Sometimes in geometry, you don't need to find every unknown quantity. You only need to find the exact combination of quantities that appears in the formula you're trying to use. Here, that combination was x multiplied by y. And recognizing that saved us from solving for the individual side lengths entirely.